Hello, welcome to this lesson of our study of vectors. In this lesson, we will just go through some examples of vectors questions involving scalar dot product or scalar or dot product. Let me put it that way. So, if you have not subscribed to the channel, kindly subscribe to support the channel. Okay, let's start. So, the first question is you are supposed to find the angle between two vectors A and B with magnitude 1 and 2, and then the dot product is this. Okay. Alright, so what you do here is that, like we know, you have to use the idea of dot product to solve this, okay? We know that the magnitude of A is giving us what? 1, and that of B is also giving us 2. This is very simple, okay? So, and we know that A dot B is also giving us 1, okay? But we know that the main equation is given by A dot B is equal to magnitude of A magnitude of B, okay, times cos theta. So what you want to find is the theta. So what we can do is we can actually find the cos theta and then make theta the subject. Okay, so let's start. Now from this, you know that A dot B is given as 1 in the question. The magnitude of A is given as 1 in the question, and that of B is given as 2, then cos theta. Okay, so simply we have 1 equals 2 cos theta, and then divide through by 2, we get cos of theta being equal to 1 over 2. So theta will be equal to the cos inverse of 1 over 2, and if you point this on a calculator, you are supposed to get 60 degrees, okay, or in radians pi over 3, okay. I hope you get it. So that is it for the question. Now the next question is find the angle between the vectors A, which is this, and B, which is that. Now with the same idea, okay, so we use the same A dot B equals this, the magnitude of B cos theta, okay, and A dot B, I hope you know how to calculate for that. That will be equal to just multiplying the components, okay, multiplying the components of each vector, and I believe you can do that. So this will give us -1. Just go through the process and you'll be able to find magnitude of A. I hope you can find that because we've already talked about how to find magnitude, and that is square root of 3. Magnitude of B is also giving us square root of 3 as well. Okay, so I hope you can go through the processes of finding the A dot B, magnitude of A, magnitude of B. Okay, so simply we just come and put them in the equation. Okay, so A dot B is equal to magnitude of A times magnitude of B cos theta. Okay, so A dot B we had what, -1, which is equal to magnitude of A, we had square root of 3, times magnitude of B, we have square root of 3, then cos theta. Means that -1 is equal to 3 cos theta. Okay, then cos theta will be equal to -1 over 3. Okay, so it means that theta will be equal to what? Cos inverse of -1 over 3. So with this, after going through your computation, the answer you get for cos inverse of -3 will be the angle between A and B. I hope these questions are very simple. Okay, so that is how the questions are. Let's go through a more tricky question. Okay, the whole of the whole of what do you call it? Okay, the whole thing in a bracket. You want to find its magnitude. Okay, let me write it well for you. Let me write it well. Okay, this whole thing. Okay, so now with that, the two vectors A and B are such that the magnitude of A is given as this, magnitude of B is that, and A dot B is that. But before that, let's learn some simple concept. Okay, for every vector, this is how you find the magnitude. Let's say P was given as P1I, okay, plus P2J. Then this is how the magnitude will be found. Okay, square root of p1 squared plus p2 squared. Now if I square the magnitude of p, this is what I get, okay? But if I dot p by itself, I get the same thing as squaring the magnitude of p. So it means that for every vector p, magnitude of p squared is the same as p dot p, okay? So it means that if you take the whole of the a minus b and we call the a minus b, like let's say c, it means that the magnitude of c squared will be the c dot c. It means magnitude of a minus b all squared will be equal to a minus b dot a minus b. I hope you get this. Now we know that a minus b dot a minus b here, if I expand this, I'll get a bar dot a bar minus a bar dot b bar minus a bar dot b bar again, and plus b bar dot b bar, okay? And that will be any vector dot itself, we are saying that is the same as the magnitude of that vector squared minus 2a bar dot a bar b bar, sorry, plus magnitude of b bar squared, okay? Now with this is how we got it. So it is this one, and we know that magnitude of a is that, magnitude of b is this, and the a dot b is that, okay? So simply magnitude of a minus b all squared will be equal to magnitude of a is what, 2, so I put 2 there, squared minus 2 into a dot b, which is 4, and plus magnitude of b, which is what, 3. I square it, okay? I square the 3, and now I get 4 minus 8 plus 9. The whole of this will give me 5. Okay, so it means the magnitude of the whole of a minus b is given as that. So it means if I'm to find a square rather, so if I'm to find magnitude of a minus b, then it will be the square root of both sides, meaning the square root of 5. So magnitude of a minus b, having magnitude of a to be this, b to be that, and a dot b to be this, is given as square root of 5. Okay, now let's move on to the next question. The next question is saying that if a bar is a unit vector and this expression holds, okay, this expression here holds, then find magnitude of x. So you see that there's a minus, there's a plus, okay, and they are the same things that are happening in the two brackets. So it means difference of two squares. So I have s bar squared, okay. S bar squared means s bar dot s bar, okay, then minus a bar dot a bar, which is a bar squared, is equal to 8 from difference of 2 squared. And now s bar dot s bar, we've learned just right now that is the same as the magnitude of that vector squared, okay. A bar squared equals 8. So it means that I have magnitude of x bar squared being equal to 8 plus magnitude of a bar squared. But we said that a is a unit vector, meaning magnitude of a is what? 1. This implies that magnitude of x bar squared is equal to 8 plus 1 squared. This will be 8 plus 1, which will be 9. So it means magnitude of s bar squared is that, which implies the magnitude of s bar will be equal to square root of 9, which is 3. Okay, so it's supposed to be plus or minus 3, but then we are interested in the magnitude, the actual number. Okay, so take note of that. So this is a solution to the question. Now you go to the last question for the day, and we are saying that find the magnitude of the two vectors a and b having the same magnitude and such that the angle between them is 60 degrees and their scalar product is that. So their magnitude are the same, so it means a magnitude of a is the same as magnitude of b. Theta is 60 degrees and a dot b is half. So meaning that this solution will be very simple. Okay, so a dot b is given as half, so let me write it. A dot b should be equal to magnitude of a times magnitude of b and cos of theta. Okay, and everything has been given. A dot b is what? Half. Magnitude of a, we are saying that is the same as magnitude of b, so we'll call them magnitude of a. They are the same. Then cos 60 degrees. Okay, so this is a half equals magnitude of a all squared. Okay, and cos 60 is what? Half. So I multiply through by half, and I'll get 1 is equal to magnitude of a, which implies squared, which implies that magnitude of a should be equal to the square root of 1, and that is 1. Okay, so it means that you are done with one part of the question. The question is saying that you're supposed to find magnitude of both A and B, okay? But you said that magnitude of A is the same as magnitude of B, so it means magnitude of B is the same as also 1, that of A, okay? Alright, so that is the simple questions I can let you through or work with you, okay? So in the meantime, we'll be taking different miscellaneous questions involving dot product and other stuff, okay? But for now, let's digest this, understand the whole thing, and then I hope we'll be able to do much in every question I've been asked, okay? Thank you, and don't forget